What's up, guys? Mr. Patterson here with another video for IB Math AAHL. This section we're going to take a look at 12E, operations with plain vectors. Operations, just think like mathematical operations, arithmetic. So adding and subtracting and also multiplying, but a special kind of multiplying is what we're going to do with these vectors here today. And the rules are pretty simple. If I have a vector A and a vector B, and I want vector A plus vector B, I'm just going to add the components together. So A1 plus B1, A2 plus B2. Same thing if I have a negative vector. Negative vector just means I'm going to multiply each component by a negative 1. So vector A is 2, 3. Negative vector A is negative 2, negative 3. Okay, pretty simple there. And if I am doing subtraction, well, subtraction is really just addition with a negative number. So A minus B equals vector A plus negative vector B. All right. Take a look at this example here. We have vectors P, Q, and R. The first one here, it says vector P plus vector R. So I take vector P, 3, negative 2, and I add to it vector R, negative 2, negative 5. I'm just going to add the components. So 3 plus negative 2 gives me a 1. And then negative 2 plus negative 5 gives me a negative 7, as we see right here. Q minus P. Okay, so here's Q, 1, 4. And I'm subtracting P, which really means I'm going to change the sign of the vectors, of the components in vector P. So I'm doing 1 minus 3. That should give me a negative 2. And then I have 4 minus negative 2, which is really plus 2, obviously, and that gives me 6. You get the message here. So P minus Q minus R, we're just going to take the components of P minus Q, and then minus R. We end up getting down to 4, negative 1. Pretty simple stuff here, no big deal. If I'm doing what's referred to as scalar multiplication, basically just means I'm going to multiply a scalar, a number, times what the components are in that vector. So if vector A is 1, 3, and I'm talking about 2A, well, that's really the same thing as saying vector A plus vector A. So it's 1, 3 plus 1, 3, so it's 2, 6. Or I could have just multiplied 2 into the components of vector A and get the same thing, 2, 6. All right. It says if K is a scalar and vector V is V1, V2, then KV equals KV1, KV2. You're just multiplying that scalar into the component form of the vector. I'm saying component form of vector because that's what they're showing here, but it could also be unit form. Unit vector form would be no different there. One thing to keep in mind here, if the scalar multiple is 0, then that means I'm multiplying 0 into the component form, and therefore I'm getting 0, 0, which is just the same thing as saying the vector 0. That's a bold 0 there, therefore it's a vector. If I take a look at this one here, I'm doing 3 times Q. Well, if Q is 2, negative 3, and multiply both components times 3, that's going to give me 6, negative 9. P plus 2Q, I'm going to multiply 2 times vector Q first, getting me 4, negative 6, and then I can add them together to get 8, negative 5. 1 half P minus 3Q, I'm going to multiply 1 half times vector P, multiply 3 times vector Q, and then I can subtract them and get negative 4, 9.5. Right? I'm going through quickly, obviously, because this is pretty simple stuff here. If I'm looking at example 16 here, I have the unit vector form. So vector P is 3i minus 5j. Vector Q is negative I minus 2j. And it says find the magnitude, right? These absolute value bars mean the magnitude of vector P minus 2 times vector Q. So the first thing I want to do is I want to figure out what vector P minus 2 times vector Q is. And just by doing my multiplying in my arithmetic there, I'm going to end up getting down to 5i minus j. So that would be what P minus 2Q is, but I need the magnitude of that now, so I'm going to use my magnitude formula, which again is really just the same idea as Pythagorean theorem there. So it's going to be the square root of 5 squared plus negative 1 squared. Therefore, the magnitude is root 26 units. That's it for this lesson. Like I told you, a nice little quick one here. For the assignment, I'd like you to work on page 284, numbers 1 through 9, left column only. Talk to you guys soon.